Okay, so in this video, I'm going to address one of the biggest issues that I see people having problems with in relation to building RAG systems or retrieval augmented generation systems. And that is that they try to use semantic search for everything. You only want to use semantic search where it makes sense to use semantic search. If you're doing search on things that would be the kind of things that are in a normal database that you would just look up an integer, look up a string, that kind of thing, you actually don't want to use those for doing semantic search. You want to do semantic search where you've got text that you're trying to extract semantic meaning out of that. So this brings us to the whole concept of self-querying retrieval. If we look at the diagram for this, we can see that the idea here is that we have a sort of step between the retrieval and the input. So the person types in their query, and then we use a large language model to reformat that query to get both the semantic elements of that, but also to be able to convert it so that we can actually do searches on metadata as we go through this. So this is a fundamental fact that if you're looking for a movie and you want to basically specify the year, you don't want to look for the year using a vector store and semantic search. You want to basically just do a lookup that looks at the year and filters the results back based on that year that you put in. Just the same if you're doing something for doing searches on Spotify or doing searches with music. If the person gives you the name of the artist, you don't want to use semantic search to look up the name of the artist. You want to do a query that looks for that artist and then uses the semantic search for doing the parts where semantic search is actually strong in this. So let's jump in and have a look at this in langchain. So we're going to be using the self-querying retriever here. I'm using openAI embeddings and the openAI models. You can swap out these for, the other models like I've done in many videos before. And maybe at some point I'll do an end-to-end example of building an app with this using Llama 2 and say BGE embeddings. I've just gone for these so that these parts are not the important part in here and the code doesn't take up too much room. So I'm using Chroma as my vector store in here. Like I said, I'm using the openAI embeddings, and then I'm going to pass in data. So this is where you would put a lot of effort into preparing your data. In this case, I'm going to be doing search over wines. And wine's going to have a number of different things in here. So you can see that we've got a description of the wine that's in here. We've got the name of the wine. We've got the year. We've got the rating that it's got. We've got the type of grape in there. We've also got the color of the wine. And finally, we've got the country of where the wine comes from. So all of these things are metadata that we're putting in. And here you can see that I've got these for a number of different wines in here. Now, which part would we use the semantic search on? We would use it on this description we've got here. So the description is what's going to be actually used for doing the search. So you'll see as we go through it that, if we talk about things like fruity notes or that kind of thing, it's able to work out that, okay, apricot and peaches are fruit. Black fruit, stone fruits, these are sorts of things that relate to fruit, citrus flavors. But if we're talking about a year, we don't want it to just do semantic search over that. We want it to use a specific year and filter by that year. So we've got our data in here, and you could spend quite a bit of time going through and working out the best metadata for your particular use case. One of the things that I see a lot of people, if they've got a CSV file, and a lot of the data would make good metadata, and then part of it would be used for the semantic search. This is a perfect example that you could do this. And you could basically write a little function that would go through your CSV file, take it out, and convert it to something like this for all your different examples. All right, once we've got these, we basically need to embed them and put them into our vector store. So this is what the last line here is doing. It's just making a Chroma DB from documents. We're passing in these documents. We're passing in what to use to do the embeddings, and it's going to embed these part, and it's going to keep the metadata separate for these. All right, so next up, what we need to do is create our self-querying retriever here. So this is something that's built into langchain. The key thing that we need to do, though, is we need to tell it the metadata info. So you can see that each one of these relates to one of the types of metadata that we've got in there. So we've got grape, which is the grape used to make the wine. We've got the name of the wine. And you'll see that these are strings or list of string in here. We've got the year is going to be an integer. We've got the country here. We've got the color of the wine. We've got the rating. Now, the rating in this case is an integer, but if you were using something like, score out of 5, and you could have 3.7 out of 5, then you would change that to be float for this kind of thing. And so the model that we're using actually knows what a Robert Parker rating is. So this is a famous wine reviewer, and the ratings that we've got there are based on that kind of rating in there. I'm not sure if they're totally accurate, but it gives you a sort of sense of this. Country, obviously that's going to be a string. And then for the semantic bit, this is going to be a brief description of the wine that we've got there. So once we've got that, we then basically set up our large language model. Again, in this case, we're just using the openAI model, but you could use Llama 2. You could use, a variety of different ones that you want here. All right, then we basically set up our retriever. We're going to pass in the LLM, the vector store. All of this is very similar to just normal retrieval, augmented generation with langchain. The next things we want to pass in is, okay, what do we actually do the query on? And also the metadata fields info in here. So these are the sort of two differences that we would do from a normal RAG system. Now you'll see that we can go through and we can query. And what actually happens is that the model will take our input, which in this case is what are some red wines? And it will write a query. Now, in this case, there's nothing semantic going on in the query, right? It's just purely going to be filtering. But the filter is going to be a comparison, and it's going to be a quality comparison. We see there, we can see that our attribute is going to be color. The value is going to be red. So sure enough, if we look at what gets returned back, we can see that we've got back these nice results here of where we've got an Italian red wine. We can see that for this color red, color red, color red, color red. So we've got a variety of different ones there. If we want to do some sort of semantic search, now where I'm saying, okay, I want a wine that has fruity notes. And it's going to basically now do the search. And I can see, okay, this wine has crisp, white, tropical fruit and citrus flavors, right? Which fits our description. You can see that we get back all the metadata as well. We've got another one where this has got dark fruit flavors. Again, that fits the fruity notes in here. So we can do a variety of different searches. What if I say, okay, I want a wine that has fruity notes and a rating above 97 in this case? So here it's got our comparator where I've got my greater than rating 97. And it's bringing things back that, again, relate to fruit. So apricot and peach, red fruit, earthy notes there. But if I say I want wines from Italy, so now this is no query on this. You can see here, the query up there for that last one was fruity, right? We can see that this one has no semantic query, but it has an equality, country, Italy. We get the Italian red wines back. What if we want to do a composite of a few things? So here I could say, okay, I want a wine that's all earthy, and it's going to be between 2015 and 2020. And sure enough, you can see that it's worked out that the semantic element to look up is earthy in here. And then here we've got an operator of and we've got this comparison of greater than year 2015 and greater than year less than 2020 in here. And it's able then to basically bring back the data that we want. So this shows us that we can do a whole variety of different searches that comprise both filtering the metadata, but also using the semantic lookup data of the vector store on those descriptions that we've got in there. Another thing that we can do is we can actually limit these things. So if we do want to just limit it to, if we've got 10,000 wines in there, probably don't want to return 5,000 wines. So we can do a limit in here. So here I'm saying, okay, and that limit is basically the model working it out in this case. So you can see here, we've got where I've put what are two that have a rating above 97. So there's no semantic query in here. We've got the greater than rating above 97, and we've got limit equals 2. So it's just probably giving us the first two in there. I want you to see that because we're using the large language model to rewrite our query, we can do things, wrong in here where I can say, okay, what are two wines that come from Australia or New Zealand? You'll notice that I've deliberately not put the capitalizations at times. And you'll find that even if, we put some misspellings and stuff like that, the language model, if you've got a good language model, will work out the difference there and be able to then fix this up. So in this case, it's returned back two wines, which is what we asked for. We can see that we've got the quality equals Australia or equality equals New Zealand there, limit equals 2. And then finally, sure enough, we get back our Cloudy Bay wine with a rating of 92 from New Zealand. And we also get back a Penfolds Grange from Australia here. So hopefully this gives you a taste of how you can build a more advanced retrieval augmented generation system that uses the concept of metadata to filter things as well as purely semantic search. So this concept will work with other language models. It doesn't have to be with openAI. I've just done that for convenience in here. Like I said, you could do this with Llama 2. You will need to make sure that you're getting a language model that can take these kind of queries and process them for this. So try this out. I find that this is a way that people can actually do a lot more with retrieval augmented generation than just the sort of minimal standard looking things up by semantic search alone. Anyway, as always, if you've got questions, please put them in the comments below. If you found the video useful and want to see more videos like this, please check out my channel, click like and subscribe, etc. I will talk to you in the next video. Bye for now.